Alright guys, this is Unit 4 Day 10 for Calculus class. So should be on, I believe it's Tuesday. Okay, Tuesday lesson. I didn't make a video for Monday because everything that we already done, the first derivative test, the second derivative test, when is the function increasing, when is the function decreasing, and so forth. So I'm going to start on this one, okay, on Tuesday lesson. Um, if it's on Wednesday, just make sure you're following the same date. Okay, so let's get started. And don't judge me. I'm trying to pull a Garza and make videos, so I'm doing my best. Right? I haven't completely mastered it, but I'm only going to be selecting a few problems so that you guys can practice on your own. Right? So this one, the do now, you should have done it. It's something that we already did or covered. So I'm going to go through this one kind of fast. So remember, guys, this was the first well, before we start anything, let's do the chart. So we have f of x, f prime of x, and f double prime of x, right? Plus, minus, increasing, decreasing, concave up, concave down, right? Positive, negative, increasing, decreasing, positive, negative. Okay, always write this because it's gonna help you in the long run. Um, yeah, it will help you in the long run. Okay, so this is first one. This graph is a graph of the derivative. Okay, so this is f prime of x. Keep that in mind. F prime is not the regular graph. So the graph of f prime of x is given. Use the graph to identify the critical points, the critical numbers. So what are the critical numbers? Well, critical numbers is when the derivative is equal to 0 or undefined. 0 or undefined. So how many critical points do we have in this graph? Let you guys think about it. So those of you who said 3, you are correct. But which 3 are we talking about? Are we talking about the critical points as the max and mins? Because that's when we have a tangent line, a horizontal tangent? Or is it when we touch the x-axis? For those of you who said the second point, that is the correct answer. So these are the critical points. So we have critical points, so critical numbers, critical points at x equals negative 3, x equals 1, and 5. Okay? Because, just so we can get used to writing the explanation, because f prime of x is equal to 0. Okay? Is there anywhere in this function where the derivative is undefined? The answer should be no, because there's no vertical asymptotes anywhere in this function. Okay? So we're done with that one. Determine whether f has a relative min or relative max at each crucial point. Okay. So remember, this right here talks about the first derivative, test. Guys, it's kind of hard to record and talk and write at the same time. Okay, so don't judge me. So first derivative test, right? So if you come up here, the first critical point is negative 3, right? If it's the function, the derivative goes from negative. Remember, negative is below the x-axis. Positive is above, right? So the function goes from negative to positive. Okay? At that point, is that going to be a min or a max? So so if we look at this way, the function or the derivative goes from negative to positive. So negative, it going downward, and then positive. So there should be a min. A min, right? Negative to positive, min. Okay? So f of x has a min at x equals negative 3 because f prime of x goes from negative to positive. Done. And where is there a max? So it has max at x equals what? Because f prime of x goes from positive to negative. So where is our max? Well, from positive to negative. That should be our max. So at that point, that is a max at x equals 5. This point, it goes from positive to 0 to positive. Positive to 0 to positive. What does that mean? Is that a min or a max or neither? The answer should be neither. Okay? Neither. Perfect. So, well, let's do this one. C. Determine the interval on the graph where it's concave up and concave down. Okay? So concave up. How do you know something concave up? Well, it's either the second derivative is positive or the first derivative concave up. Come to our chart. If it's concave up, the second derivative is positive or the first derivative is increasing. Right? When is it concave down? Right? When the concave down is when the second derivative is negative or when the first derivative is decreasing. Right? So second derivative is negative or when the first derivative is decreasing. Okay? So from negative infinity all the way up to negative 2. Is that going to be concave up or concave down? What is the derivative? Remember, this is a graph of the derivative. This right here, the derivative is increasing. So if the derivative is increasing, it is concave up. So I'm just going to write it on the side. So concave up from negative infinity, negative infinity, all the way to negative 2. Okay? Where is it concave down? Well, wherever the derivative is decreasing. So from negative 2 all the way up to 1. That's where it is decreasing. From negative 2 to 1. Concave down, negative 2 to 1. Okay. On the next part. Also, here from negative 1 all the way up to 4, the derivative is increasing. Remember that we're not looking for positive or negative, we're looking for increasing, going upward, traveling upward. Here, it's negative, but it's still increasing. Positive, still increasing. All this is increasing. All this is increasing. So it's increasing from 1 to 4. So concave up from 1 to 4. Okay? You can write the word and, you can put union, however you guys like. Okay? Both are correct on the AP exam. Okay, union is a big, like, you looking one. You cannot put, you cannot use this symbol. This symbol is the intersection. It means something else. It's not and. And then the last one, from 4 to positive infinity, the derivative is decreasing. That's where it's concave down, from 4 all the way to infinity. And. Okay, so that's the answer to C. Make sure you write the explanation, because the first derivative is either increasing or the first derivative is decreasing. Okay. Before we go on to the next one, I want to show you how this graph would look. Okay. So we have a function. Okay. So we know that at negative 3 there's a min. So 1, 2, 3, and negative 3, there's a min, so let's just put our min right here. Okay, and we know that at 5, there's a max. 1, 2, 3, 4, 5, there's a max. Okay, so we know it's going to be a min right here, so we know that. So right here, at x equals 1, x is equal to 1, the derivative is 0. What does that mean? So as x is equal to 1, the derivative is 0, that means that there is a flat line, there's a horizontal tangent. Okay, so this part gets a little confusing. So the derivative is increasing, or the derivative is positive. So if the derivative is positive, the function is increasing. The derivative is positive, the function is increasing. So right here, the function is, or the derivative is positive, so therefore the function is increasing. But at that point, at x equals 1, it goes flat, and then it starts getting more positive. So therefore, it starts increasing again. We can clearly see that it is increasing on this side and also increasing on this side. At that point, at 1, there is a horizontal tangent. Okay, and that's what that means. From positive to 0 to positive. So it's increasing to 0 to increasing. Okay, that is not a max nor a min. It's just one of those weird points. Okay, and then there's a maximum at x equals 5, and then it shoots down. Okay, so this is how our graph should look, right? There's a max, a min, the function is increasing, decreasing, right? So this is f of x, okay? This is f prime of x, don't get confused, okay? You need to know how to read this graph, because this little part, that little part is gonna come up on the next problem that we do. Okay, so press pause and see if you guys can try to find the answer to this one. So someone press pause and try to work it out, and then press play when everyone already tried it. So wait like, I don't know, 5-10 minutes. All right, so I'm expecting you guys to press pause and work it out, okay? But let's start doing it. So same thing from before, right? So what is it saying? So the function is continuous. That's a key thing, guys. Continuous. That means there's no breaks. There's no vertical asymptotes. There's no. It's continuous. Okay. There's no breaks. So no breaks. Okay. On the closed interval between -3 and 3. So that means anywhere in between those points, it is continuous. Okay. Such that f of -3 is 4 and f of 3 is 1. Okay. These are the two endpoints. Okay, it's continuous, including the endpoints. That's what the brackets mean. Okay, now, so this looks like our table. Okay, so this is the first derivative, and that's our second derivative. Okay, good. So right away, guys, just so we can break it down, what are our critical points at x equals what and x equals what? What's the definition of a critical point? Is when the derivative, let me just write this. The derivative is equal to 0 or undefined. So we have critical points at what? The derivative is undefined, fails to exist, undefined, interesting, as x equals -1, and the derivative is equal to 0 at x equals +1. So those 2 points are our critical points. Okay, those 2 points are our critical points. Okay, so now that we're in that notion, how can that be possible if the derivative doesn't exist but the function is continuous? What do we know about the derivatives? So what do we know about something that's non-differentiable, where you can't take the derivative? Think about your vocabulary words. Non-differentiable, right? Corner, cusp, vertical tangent, and all the continuities, right? So right here, since the derivative does not exist, more than likely it has to be either a vertical tangent, a corner, or a cusp. Okay, it cannot be a vertical asymptote because the function is continuous. There's no breaks. Okay, just so you guys are aware, just so you can start thinking of that logic. Okay, corner, cusp, or vertical tangent. Okay, those are where it's continuous but not differentiable. Okay, all right. Anyways, so first one. What are the x-coordinate of all the absolute mins and absolute max on the interval between -3 and 3? Justify your answer. Oh shit. All right. So where are your max? Well, is when the first derivative goes from positive to negative or negative to positive, right? So absolute maximum is when the derivative goes from positive to negative, or the absolute min is when the derivative goes from negative to positive. Okay, we got to be careful with that because you can still have, if you look at this one, you can still have a min, but that's not the absolute min, right? This is your absolute min. So you still got to be careful and check if it's the absolute and not the relative. This is a relative, that will be your absolute. So here, so an absolute max, positive to negative. So if we know that the function starts at -3, right? That coordinate -3, y is 4, right? So at -3, it starts. The derivative is positive. So if the derivative is positive, that means the original function is traveling upward. It's increasing. And then at this point, that's when it switches to negative. So this right here should be our absolute maximum. Okay? It's an absolute maximum at x equals -1. Okay? Justify your answer, right? Because from -3 to -1, the derivative is increasing, right? Therefore, f of x, or the derivative is positive. Sorry, positive. Therefore, the function is increasing, right? Then you say the other point. Then from -1 to x to 1, f prime of x is negative. Therefore, f of x is decreasing. Okay, and then you can go on saying that here it's also negative, so therefore this must be your highest absolute maximum. Okay, sorry guys, it's I have very little room and I can't explain it fully and write out the full sentence because it's one hand. Okay, so replay the video. So it's an absolute max because the derivative is positive, which means that the original function is increasing, is going upward, and then at the rest of the other points, the derivative is negative, so therefore it can only travel downward. So at this point, at x equals -1, that is your absolute max. Okay. Now here, what is your absolute min? So if you listen to what I just said, since the function travels upward and then the rest of the two things is traveling downward because the derivative is negative, the absolute minimum point should be at the very end, because here it's still traveling downward from 1 to 3. It's still negative. It's still traveling downward. Okay, so where should be the absolute min? At x equals, at the very last point, 3. At the very end, because the function is still decreasing between -1, or between 1 and 3. The derivative is negative, so the function is still decreasing. So at the very end, that will be your absolute min. Okay? Don't worry, guys. I'm going to explain this a lot more later on. Now, D, or B, I'm sorry. Sorry, let me catch my breath, guys. I was talking too much. All right. So, what is your x-coordinate of the points of inflection, right? On the interval between -3 and 3. So points of inflection, that's when it changes concavity, right? Basically, the changing signs of the second derivative. Okay? So it goes from positive to negative, the second derivative. So where is our only point of inflection? When it changes signs from positive to negative, so at x equals 1. That is our only point of inflection. Okay? If this was negative, so it goes from negative to positive to negative, would this be a point of inflection? The answer should be no. Okay? Points of inflection, the second derivative has to equal 0. Points of inflection, the second derivative has to equal 0 and a sign change. Okay, it cannot be undefined. It has to be 0. Okay, hopefully this video helped, guys. I miss you guys, so I'll make another video for the next lesson. All right, guys, take care.